Alright, in this video we're talking about relations and functions. And there's four ways to represent a relation. There's the graph, which you and I know from Algebra 1, where we graph points and you can see the relationship with each point represented. Okay, the next way that you can represent a function is through ordered pairs. Inputs, which is always your x, and your output, which is always your y. And this is the same points that are on the graph over here. We just wrote out the point values of these points. So we have 5, 1, negative 3, 2, negative 2, negative 5, way down there, 0, 0, 2, 2, 4, 6, and 5, negative 2. Same points, different representation. Right? Yet another representation of those same points is a table. Okay, X and Y table. You've seen that your whole life. Then a fourth representation is a mapping diagram. It's where you take the X values and map them to the Y's. So for instance, I'm going to take the X values in my input column right here and put them in the Y column, or Y map, I'm sorry. Okay, to map these, we're going to take the X values and put them in order from least to greatest, Y values, put them in order from least to greatest, and then map them. So I'll show you what I mean. X values will go negative 5, negative 3, negative 2, 0, 2, 4, and 5. Y values, okay, it goes from, let's see, negative 5, I have negative 2 two times, then it goes 0, 1, 2, and 6. Then I've covered all the Y values. Now to map them, you just simply draw arrows from whatever point, whatever X goes to whatever Y. So negative 5 goes to positive 1, so draw an arrow like that. Negative 3 goes to negative 2. Negative 2 goes to negative 5. 0 goes to 0. 2 goes to 2. 4 goes to 6. And 5 goes to negative 2 as well. Alright, it's still a function, even though two things point to one Y value, it's still a function because all your X values are unique. Now, domain and range. So the domain of my function here is, we always use the curly brackets, is the X values, okay? So the domain is negative, and you put them in order least to greatest again. Negative 5, negative 3, negative 2, 0, 2, 4, 5. Range, brackets again, negative, or least to greatest, so it's going to go negative 5, negative 2, 0, 1, 2. Alright, so is this a function, yes or no? What you want to look for is that all the X values are unique, and these X values are not repeated. Y values can be repeated, like we have a negative 2 here and a negative 2. That's not a big deal. But X values cannot repeat. So you would say yes, and you would say each input unique. Okay? No repeated X values. That's what I mean by that. Now, domain. You may or may not recall this, but domain is the set of all inputs. All the input values of a function, also known as the X values. Okay. Range is all the output values, also known as your Y values, in a relation. Okay. Domain is all the X values that you put into it, and range is all the Y values that come out. A function is a relation that has only one input, for every output. So in other words, so one independent variable per dependent variable. One independent variable for each dependent variable. Okay? If you remember, the independent variables are x's and your dependent variables are the y values. Okay? Alright, look at this example. We're going to list the domain, the range, and determine if each one is a function. So let's say I have this set of x values and it goes negative 3, negative 2. Alright, so I have these x's and y's and I would need to see how they map out. So 3 goes to negative 1. Alright, so I look at this and I decide, do any of these x values map to a different y value? Like, are there two arrows coming from any of the x values? Well, if you look at this, each arrow coming from the x value here is independent. Like, they're unique. These x values are not getting repeated, so this is a function, okay? The domain of this guy lists the x values, least to greatest, and the range of this guy lists the y values, least to greatest. All right, let's try example 2. List the domain, the range, to determine if they're a function. Okay, let's do domain here. Domain, whew, that's a terrible bracket. So least to greatest x values. So we'll go -4, then -2, 1, and 2. Ranges, range values. Let's go least to greatest. Let's say 3, 5, 6, 8, 9. Okay, so notice something weird here. There's only 4 x values and there's 5 y values. So you should see that this 1 right here, if we were mapping it, that 1 would have 2 arrows coming from it to 2 different y values. Because that x value gets repeated, this is not a function. Okay? Example 3. Right? So from a graph, we got to decide, is it a function? Really simple. Okay, let's do domain and range. Least to greatest. So let's look at our furthest x value from left to right. Is -3, -2, 0, 2, 4, and 9. Okay. Range values. Okay. Let's look at our y values from least to greatest. So start at the bottom, work your way up. This goes 1, 4, 5, 6. So this is -6, -5, 0, 2, 4, 5. All right. Now, again, look at this oddity. We have more range values than we do domain values. That is a clue that this is not a function. Okay, notice that right here, that x value has a positive y value and a negative y value. Okay, so this one is not a function either. All right, moving on. All right, the vertical line test. It is a test that's real easy to use. Vertical line states that if a vertical line passes through more than one point on the graph of a relation, then the relation is not a function. All right, not a function. So use the vertical line test to determine if each graph represents a function. Well, if I draw a vertical line straight through this, it only hits one place, so this is a function. Number 2, vertical line test, look, it hits in 2 places, so this is clearly not a function. Number 3, vertical line test, it only hits in one place, so this one is a function. All right, it's easy as that is. If you go back to the example we previously did, this right here would not pass the vertical line test because look, the vertical line goes through both points. That's another clue this is not a function. Okay, moving on though. Finding domain and range of continuous graphs. Okay, you're going to need to use set builder and interval notation to describe the shaded regions. All right, open circle. So this is saying that x is less than -3. Hopefully that makes sense to you. So for set builder, the notation of that would look like this. We have the curly bracket, and then we say x such that x is less than -3. Curly bracket. All right? Interval notation, it comes down, remember what this arrow points to. It points to -infinity. So we always put a parenthesis with -infinity, and we read from left to right, and we come up to -3. But because this is an open circle, you can think of it as a parenthesis, okay? Then you would put a parenthesis on that. These two things mean the same thing. This is set notation up here, and this is interval notation. Let's try the next one. All right, look at number 2. So here's x. It can be -2, and anything between -2 and 4. It includes -2 because it's a closed circle, but it does not include 4. All right? So set notation would look like this. Curly bracket, x such that x is between these two guys, right? So it's going to be between. So x is, all right, let's try this example 2 here. So we need to write this one in our notation. So consider this. X is here, right? X is any value. It could equal -3, but it doesn't equal 1. We know it's less than 1, doesn't equal it, but it is greater than, so think wisely here, it's greater than or equal to -3. So when x is between two bookends like this, your inequalities need to face the same direction. Sometimes it's easier to start on the right side and then mirror it on the left. Then you make sure you put the or equal sign if it applies. So in set notation, this guy would look like this. Bracket x such that such that, and then we repeat what we did over here. We go -3 is less than or equal to x, which is less than 1. And then there you go. Now in interval notation, we would use a bracket on the closed circle and a parenthesis on an open circle. So we'd say -3, comma, 0, parenthesis. That's all you have to do. All right, it's assumed that x is in between those two. All right, let's try number 3. So here's x, and here's x. It could be two different things. So we have an or situation, okay? This is an or situation. So let's take one little piece at a time. So x has to deal with -2. It's less than -2, but not equal to it. But it's greater than -4. And it could be equal to it, so we do the or equals to. Over here on this part of it, the endpoint is 4 and the endpoint is 0 again. Now, x cannot equal 0, but it's greater than it. But it's less than 4. And it can equal 4 because it's a closed circle. All right? So the way you would put this in set notation looks like this. Curly bracket, x such that, and then we list these two inequalities that we just wrote. We would say -4 less than or equal to x less than -2, or 0 less than x less than or equal to 4, and then close your bracket. Interval notation is quite similar. Okay, consider this. Closed circuits are always brackets. Open circles are always and this one's a bracket. So we just repeat our numbers. We would say bracket -4 to -2, or 0 to +4 with a bracket. All right? So that's how you handle set notation and interval notation for each of those possibilities. Now let's look at some other graphs. We're going to do domain and range of each graph in set builder and in interval notation, and determine if it's a function. Now, before you would dive into this, I would recommend that you always figure out these endpoints and study them. This is an open circle, and that's at -2, -5, okay? And up here, it's a closed circle, and that's at 3, +5. All right, domain is always your x values, right? And we're saying this is the betweener. X is between -2 and +3. So to set notation, we would do this. We'd say x such that -2 is not equal to, but it is less, x is greater than that, and it's less than or equal to a 3. Range, same idea, just look at the y values. Okay, range is y, so y such that it goes -5 less than y less than or equal to +5. All right, notice we changed our variable because we're dealing with x's and y's. Interval notation, we would write this as parentheses, because it's not equals to, -2, comma, to 3. Bracket on 3 because it's a closed circle. For the range, parenthesis, -5 to +5. Bracket. Try the next one. Now, find your endpoints right here. The sky appears closed, and means at 1, 2, 3, 4, -4, +4. All right? Now, look at this point right here. This is the lowest point of the graph, right? And what is this guy over here doing? Well, he's going in the direction of +infinity, isn't he? He's actually going in the direction of +infinity of the x's and the y's. All right, so keep that in mind. Now, I bring this up because I want you to notice what's the lowest y value here. When we read range, what's the bottom to top, okay? The lowest y value here is 0, okay? So the whole graph goes from 0 on up. That's what this is saying. So let's look at this. Our domain is x values, right? So we read left to right, just the x's. It goes from -4 all the way to +infinity without any breaks, okay? So we would say x such that -4 can be greater than or equal to, and it's less than infinity. Okay. Now, with range, you switch to a y, and you would consider the lowest y value here, read from bottom to top, goes from 0 all the way up to what? Positive infinity. This 4 is included from that range from 0 to positive infinity. 0, it would be close because that line goes right through it. So it would be 0 greater than or equal to 0, which is less than, or y is, I'm sorry. Now in interval notation, my domain would look like this. All right, it's less than or equal to, so I put a bracket on the 4, negative 4, and I would put a parenthesis on the right side, and anytime you put parentheses, I'm sorry, the infinities, anytime you put the infinity sign, you always put parentheses with it. So with range, it goes from 0, but there's a bracket there because it goes through 0, comma, to positive infinity. All right, let's try this one. Notice your graph, okay? Left to right, okay, notice this guy's going down, right? That basically means he's going negative infinity in the x direction, because he's going all the way out of here, and he's going to negative infinity in the y direction, going both ways. This point is a key point here. 1, 2, 3, 4. Okay, that's as far right as this whole graph goes. Now look about how high this graph goes. That's important too when we talk about range. 4 is my highest value for y. Okay, so let's put this in notation. For domain, left to right, it goes from negative infinity to 4. Now, this would be x such that negative infinity is less than x is less than or equal to where x is 4. For the range, sorry, this should be range and this should be, notice that typo, I'm sorry. So for the range here, this would be y such that the lowest y value is negative infinity and the highest y value is way up here at 4. So, and it can equal 4, so it's less than or equal to 4. All right? Now, the interval notation for domain would look like this. It would be parenthesis negative infinity to a 4 with a bracket because that 4 is closed, it's included. Range would go from negative infinity, because it's an infinity, always has a parenthesis, all the way up to a positive 4, and that has a bracket as well. All right, let's try a couple more of these. All right, low point here, what is that? 1, 2, 3, negative 3, negative 1. And this guy over here, he's going to negative infinity and positive infinity in y. Negative infinity x, positive infinity y. This guy with an arrow goes to positive infinity, positive infinity. So this is my x, this is my y. So that's important key elements to my graph. So in set notation, I would say this, x such that x is all these values. So it goes from negative infinity, each x is between negative infinity and positive infinity. Range, bottom to top, okay? The lowest y value, negative 1. What's the highest y value? Well, that's positive infinity. So my range would look like this, y such that negative 3, negative 1 is less than y, which is less than all positive infinity. Negative 1 is less than y, which is less than. Interval notation would look like this. This goes from negative infinity to positive infinity. So it's just all parentheses, all infinity. Range would go from negative 1, and it would be a bracket because the line goes straight through it, and to infinity, it would always be. All right, let's look at one more. Okay, left and right. Where's this guy going? Well, this guy is going to positive x's and positive y's. Okay, this is going positive x's and negative y's. This arrow down here is going in the positive x direction, but in the negative y direction, right? Now, this is important because that's kind of like where the whole graph starts. When we start reading it left to right, it doesn't even start till 0, 0, right? That's the 0, 0 point. So that's important because if we look at x values, it goes from 0 to positive infinity, and that's it. So our notation would look like this. X such that 0 is less than x is less than positive infinity. In interval notation, this should be a D. It would look like this. It would say there's a bracket because it does exist at 0, and it goes to positive infinity. And this should say R for range. Set notation for range would look like this. Y such that When we look at what is our lowest y value, well, it's negative infinity. What's the highest y value? Positive infinity. So we simply say negative infinity is less than y is less, and then in interval notation it would be 2 parentheses with a negative infinity. All right, if you've taken pre-cal, you've seen this before. If you haven't, maybe new for you, so you may need a little extra help. Now look at number 6. Let c of x equals 1.99x be a function that represents the cost in dollars, c of x based on the weight of grapes in pounds. All right, so let's think about this. We want to know what's the domain and the range of the domain. Let's think. What are all the possible x values? How many weight of grapes in pounds? So what's the lowest amount of pounds you could get in grapes? Well, that's from 0 to anything, right? Anything at all. So that would be an interval notation. It could be 0, so I could put a bracket on that. But if it's infinity, I would leave it a parenthesis. All right, so let's think. On our range, the cost is going to be 0. If I put a 0 in for x, that's still 0, right? The function, so it would come out 0. And if I put infinity in for x, that means my number is going to be 1.99 times infinity, which is really, really big. So my range is infinity as well. Now in set notation, easy enough, x is between 0. It can equal 0, so it's less than or equal, or it's greater than or equal to 0. And it's less than n. And for y is such that, oh, I didn't do this. Y is such that 0 is less than or equal to, y is greater than or equal to 0, which is less than or equal to infinity. Okay, so you just think in context. Grapes, you can't have negative pounds of grapes, so I can't have anything less than 0. That's what my logic, right? Last thing is function notation. If you've been in pre-cal, you've seen this, maybe even in algebra 2. Shouldn't be too bad. If f of x is x squared plus 4x and g of x is 5 minus 3x, then find the following. So A says find f of negative 3. So that means I just focus on this first equation, and that's it. All right, and negative 3 means I plug that in for x. So I'm going to take my equation, which says x squared plus 4x, and I'm going to put in negative 3 for x. Well, negative 3 times negative 3 is a positive 9. 4 times negative 3 is negative 12. So that gives me a negative 3. Easy enough. G of negative 5. So I take the g equation, and I plug in a negative 5 for x. Order of operations says I need to multiply this first. So negative times a negative is a positive 15. So 5 plus 15 is 20. And I'm done. C is g of negative 2/3. 5 minus 3x again, and 2/3. Don't freak out because it's a fraction. 3 over 1 is just 3, right? When you multiply fractions, you just go straight across. So I'm going to leave the 5 alone. And I would, if I go straight across, I have two negatives, right? Negative times negative makes it positive. 3 times 2 is 6. 1 times 3 is 3. Well, that simplifies to 5 plus 2, which is just a 7. All right? So function notation is pretty simple. So hopefully you've seen this before and you will do well on your homework. Let me know if you have questions.